Good afternoon. My name is Ravi Babu, Assistant Professor, Civil Department, IARE. Now I am going to explain about the problems on stability analysis using bilinear transformation and Routh stability criteria. Class we will see that it is the topic of stability analysis. In previous sections, we see that what is meant by stability, what is meant by asymptotic stability, internal stability, bounded input, bounded output stability, jury stability, and RH criteria. Now, today we are going to see about extra problems on stability analysis. That is, first of all, I am taking the characteristic equation as P of Z equal to Z cube minus 1.3 Z square minus 0.04 Z plus 0.24. Okay. Now, when I am going to calculating the RH criteria stability, that is, it is in that one, we have to first of all replace that one where Z will be there, that is W plus omega plus 1 by omega minus 1. You have to replace this value omega plus 1 by omega minus 1. So Q of W equal to, it is coming to as omega plus 1 by omega minus 1 whole cube minus 1.3 into omega plus 1 by omega minus 1 whole square minus 0.08 into omega plus 1 by omega minus 1 plus 0.24. Okay, after substituting these values, we have to get as, if simplifying the above equation as Q of W is, we are getting as 0.14 omega cube minus 1.06 omega square minus 5.1 omega minus 1.98. So, so we have to maintain first of all where omega z is there, that we have to replace with omega plus 1. Okay, so we have to simplify this equation as this one. After that one, we have to maintain the RH criteria table. Already we know in theory construction part what is the RH criteria table. When going to writing the RH criteria table, we have to first of all write the components highest order of the n. That is, here the order is n equal to 3. N equal to 3. So omega cube and omega square and omega 1 and omega naught. After that one, from the polynomial equation, the characteristic equation, we get the omega cube value. So we have to write down the omega cube and omega square values only. Up to here we have to write. That is omega cube is nothing but it is the odd power. So we have to take the odd power values here. That is, it is 0.14. After that one, the odd power is omega 1. What is the coefficient of the omega 1 value we have to take? That is minus 5.1. We have to take it as next quantity is omega square. That is even numbers. That is minus 1.06. So it is odd and odd. Even it is omega naught. So we take even minus 1.06 minus 1.98. Okay, you have to take this one. So after calculation of this one, we go for the omega 1 value. So what is the omega 1 value? Omega 1 value is nothing but BD minus, if you take this is one is, it is A, it is B, it is C, it is D. Okay, BC minus AD by, okay, or AD minus BC, anything. Okay, BC minus AD by C you have to take. Okay, BC minus AD by C we have to take. So this value is nothing but, here the value is minus 5.36. Okay, that is BC minus AD by C. That is, what is the BC value? minus 5.1 into C value is minus 1.06 minus A value is 0.14, okay, into D value is minus 1.98 by C value is minus 1.06. If you solve these one, we get as minus 5.36. Minus 5.36. It is omega 1 value. Okay. After that one, the next value is it is there is no content is there. That's why it is coming to 0. It is coming to 0. It is coming to 0. Okay. So it is 0 value. Okay. Completed. Omega 1 value is completed. Now, what is the next lower value of the coefficient? That is omega naught. When you go into omega naught finding, so the ABCD parameters are going to be changing. That is, it is coming to as A, it is coming to as B, it is coming to as C, it is coming to as D. Okay, so it is A. Next, go for the next one. Omega naught value, that is nothing but BC minus AD, that is 5.36 BC minus AD by C. Okay, so it is 5.36 into 1 minus 1.8 minus 1.06 into 0 by minus 5.36. Okay, C value. So it is cancelled. It is 0 value. So only remaining is minus 1.8. We got it. So we got it minus 1.98. Yeah, minus 1.98. So completed. Now, coming for the conditions of the Routh criteria, stability conditions. That is, there is a one sign change in the first column. There is a one sign change in the first column of the Routh array. So that is from here it is plus. So one sign change. One sign change. From here to here there is no sign change. Here to here there is no sign. So it is unstable. Okay. That is one pole in the right hand side of the double plane. Okay. So that is nothing but in case of the Z circle, it is out of the plane. That is nothing but if you take Z circle here, it is Z circle here. Okay, how many poles totally? 3 poles. Okay, 3 poles. In 3 poles, one sign change is nothing but one pole is outside the circle. So here one pole, anything. Here one pole. Remaining 2 poles are inside the circle. So system is unstable. System is unstable. Okay, all of understand. Already these concepts are explained in theory part questions. Theory part questions. Next, coming for the next question, that is already this same question I am continuing with different values. That is order of the power 4. Order of the power 4. That is the given characteristic equation is z power of 4 minus 1.2 z cube plus 0.072 z square plus 0.3 z minus 0.08. Coming for next one is same as replace with omega plus 1 by omega minus 1. Omega plus 1 by omega minus 1. So we have to replace this one is with where z value is there. That is, it is coming to as q of z and omega plus 1 is replacing. After this one, simplifying this one equation into normal equation, polynomial equation, we are getting this equation. Okay. 0.09 omega cube plus 1.32 omega square plus 5.38 omega square plus 7.32 omega plus 1.89. We got it this value. After that one, we have to maintain the RH criteria table. Sorry, RH criteria table. That is, what is the n value here? Power is 4. Power is 4. So, what I am saying is the power is 4. So, n value is 4. Okay. So, omega 4 and omega cube and omega square, omega 1 and omega naught. It is omega naught. Which is value 1 of, so omega naught. So, after that one, form the values, enter the values. That is, only you have to enter these two values only. It is omega power 4 is the even number. And what is the even number? Other one is even number. Okay, it is even number. Okay, so omega power values is row value is 0.09 and 5.38 and 1.89. Completed. Next, omega 3 values are, it is odd number. It is odd power value. So 1.32 and 7.32. 7.32. Okay. Now coming for the next one, duty table. What is that one? I want to omega square value. I want to omega square value. So if I want to omega square value, first of all, same as it is A, it is B, it is C, it is D. So BC minus AD by C. So this value is 1.32 into 5.38 minus 80, 0.09 into 7.32 by 1.32. If you calculating this value, we are get the 4.8. 4.88 completed. Next. Next one. Coming for next value. That is, if you take this one, it is completed, no? So it is completed. Next you take, this is B and this is D. Here 0 value is there. This is D. Okay. So BC minus AD by C. That is nothing but 1.32, 1.89 minus 0.09 into 0. So its value is by C value is 1.3 to 1.3 cancel. So only it is 0 value. So only 1.89. 1.89. 1.89. Okay. This is completed for omega square. This is completed for omega square. Next. Coming for the, it is A, it is B, it is C, it is D. Okay. BC minus AD by C. That is 4.88. 1.32 minus 1.32. 1.88 by 4.88. So we have got 6.81. 6.81. Okay. So next term is not there. So next term is not there. That's why it is committed 0. That's why it is committed 0. Now coming for next one is A, B, C, ABC, AC, B. Sorry. Okay. So 6.81 into 1.89 minus 4.88 into 0 by 6.8. This one cancel. 1.8 is there. Okay. So it is a RH criteria table formation. RH criteria table formation. Now check the conditions for the stability conditions. That is, any row sign changes will be there. So it is plus, it is plus, it is plus, it is plus. So there is no changes. All are positive. That's why system is stable. System is stable. Okay. There is no sign changes in first column. That's why it is called as a system is stable. So how many rows are there? So it is, there are 4 rows. So 4 rows are in the S circle is are inside the X circle. Inside the X circle. So system is stable. Inside the circle is there. So this is system is stable. Next. Coming for the next problem, third problem. Consider the system as shown in figure. Find the range of K for the system. Okay, stable condition are. So they are given as condition as system is stable. They want to K value. They are given as K of G of Z equal to K into 0.084 Z square plus 0.1 Z plus 0.019. So Z cube minus 1.5 Z square plus 0.553 Z minus 0.05. Okay. So input is they given as R of S, and with the feedback, unity feedback, that is E of S, and one pulse function is applied with the time signal as t equal 1 second. Okay, and pulse function is this one is E star of S, and one forward gain is they are applied, that is K. The given as a system is 1 minus e power of S by S into 1 by S into S minus 1 plus S into S minus 2. They given. Okay, and there is one forward path with the G of S. G of S. For this one, first of all, they have to write the characteristic equation. That is, they given the characteristic equation already in problem. Okay, they given the characteristic equation problem. This is your characteristic equation. This is your characteristic equation. They given already. So this is your characteristic equation. Now, coming from that one. This is your characteristic equation. No? So denominator part. Okay, Z cube into, what is that one? Characteristic equation. Z cube into 1.5 Z square plus 0.05 Z minus 0.05. Okay, 0.05 plus K into formation is coming. So characteristic equation. Okay, 1 plus characteristic equation G of S by H of S equal to 0. Then you take that final value is coming to as like this. It is Z cube plus 0.05 is coming like this. It's coming to like this. Okay, first of all, we have to find the given problem is in block diagram. But don't confuse the given block diagram. But also in a problem, the given function also, the transfer function of that function. Okay, so we have to take only the transfer function characteristic equation. That is 1 plus G of Z. 1 plus G of Z equal to 0. Equal to 0. So we have to make it as transfer function of this characteristic equation. Okay, characteristic equation. That is 1 plus this one. That is your characteristic equation. After solving this one, we are getting as denominator part equal to 0. This characteristic equation denominator part equal to 0. So that is P of Z equal to this part we are getting. And after that one, they are saying that system is stable. Okay, system is stable. So how can you find the RH criteria in case of digital control system by using bilinear transformation function? That is, where Z is there, we have to replace, that is omega plus 1 by omega minus 1. Omega minus 1. So replace that one. That is omega plus 1 by omega minus 1 whole cube plus this part into omega plus 1 by omega minus 1 whole square plus this part into omega plus 1 by omega minus 1 into this part. Okay, that is up to that one. After that one, by solving this equation, we got the final equation as 0.03 plus 0.27k into omega cube plus 1.1 minus 0.11k omega square plus 3.8 minus 0.27k into omega plus 3.1 0.00k. So form the RH criteria. The given is the problem they given as by using bilinear transfer function of this system, by using bilinear transfer function of the RH criteria. So what is the highest power is there? Omega cube is there. Omega cube is there. So omega cube, it is sub to this value 0.03 plus 0.27k. Okay. Next one is 3.8 minus 0.27k. This is omega cube. Odd numbers, magnitude values. Okay. Next 1.11 minus 0.11k. Next one is 3.1 plus 7.00.7k. Okay. This is odd number values. And odd and even number values. Now, go for the next one. Same process. That is, it is A, B, C, D. That is BC minus CD by C. BC minus CD by C. That is 1.1 minus 0.11k minus, into 3.8 minus 0.27k minus 0.03 plus 0.27k into 3.1 plus 0.07k by C value. What is C value? 1.1 minus 0.11k. 0.11k. Okay. So that is nothing but after solving this one, we got the value as this one. See the denominator value, see the denominator. Only denominator value multiplication, multiplication, this one. Denominator value is same. Denominator value is same. After that one, what happened? We go for the next one, rho. That is omega naught. That is omega naught. It is zero value. Same. It is A, it is B, it is C, it is D. So BC minus AD. AD value is 0. Okay. BC minus AD by C. CC value cancel. Only B value is there. B value. 3.1 into 0.07 K value. Okay. That is BC minus AD by C. Okay. AD D value is 0 now. That's it is 0. Only BC is there. After that one CC cancel. Only B value is coming. That is this value. This value. Okay. Completed. RH criteria is completed. After that one, in the problem they given as the system is stable condition. The system is stable condition. See this one. They given as system is stable condition. System is stable condition. So we have to find stable condition. We have to find the K value for that one. See, there is a different cases is there. First of all, the last term 0.03, the system is stable, nothing but all the elements of the first column should be same sign. It is positive or negative, we don't know. But first of all signs will be same. So the condition for the stability in terms of K as 0.03 plus 0.07 greater than 0. Greater than 0. That is 0.03 minus 0.027. First column. It is first column now. It should be greater than 0. Greater than 0. First column. All because they given as system is stable. When the stability is all first columns are same sign. First columns are same sign. That is, if it is positive or negative, it is positive or negative, anything. All signs are same. First column signs. So I am taking it as positive. That's why it is greater than 0. So it is greater than 0. For solving this one, K value is getting as minus 0.11. Next, second one. 1.11 into 1.0.1K. So greater than 0. It is greater than 0. So K value is getting as this part. Greater than 0. That is the 0 denominator part is going to be 0. So denominator part is there greater than 0. We are getting as K is less than 0.275 or K is greater than 140. Last one. 3.1 plus 0.07 K. Okay. So it is coming to as this one. 3. Greater than 0. So from that one, we got the K values 4.44. 4.44. So it is the conditions. These conditions are taking as I am when the system is stable condition. System is stable condition. So it is I am taking. What happened? They are asking the K value. That is, by seeing these values, which one is the lowest value in negative section? It is 0.011. 0.011. Between K is between 0.01 less than or equal to 2.74. 2.74. It is your K value. Okay. When the system is stable condition, we have to find the K value is this one. Find the K value is this one. Coming for the next one, singular cases. Next topic is singular cases. Okay, singular cases. In RH criteria, what is the singular cases we have to see? That is, in RH Routh table column may be and in occurrence with any following conditions. That is, the first column in any row is 0. All the elements in a single row are 0. Okay, all the elements of single row is 0. That is, we have to remember that the first case is replacing by small number of zeta, and then proceeding with the tabulations. Stability can be checked for the limiting cases. That is, second regular case indicates the one or more following cases. What is that one? That are pairs of the real roots with the positive sign for pairs of the imaginary roots and pairs of complex conjugate roots which are equivalent from the origin. Where in row of all zeros occurring in auxiliary equation, that is all zeros into all zero is formed by using the coefficients of the row just above the row also are zero in this condition also. So the roots of the auxiliary equation are the roots of the Cauchy equation. It is nothing but the translation of the concerning the replacing the word. So that is d omega of the dA omega. See the problem. With bilinear term. Any singular cases is coming. Okay. They are mentioned here like this conditions. So similarly, we go for the same problem. And taking as this one by using bilinear transformation. So we have z equal to z cube minus 1.z square minus z plus 0.8z. Okay, where z is there omega plus 1 by omega minus 1 whole cube minus 1.7 omega plus 1 by omega minus 1 whole square minus omega plus 1 by omega minus 1 plus 0.8 plus 0.8. After simplifying this one, we got the equation as 0.9 omega cube plus 0.1 omega square minus 8.1 omega minus 0.9 equal to 0. So after this one, we are getting as 0. First row is omega cube, highest column omega cube. So 0.9, 0.181, 0.1, 0.9. Okay, 0.9. So this one you have to take as AD minus BC. So it is A, B, C, D. Okay, BC minus AD by C. So what happened this one? Okay, minus 0 minus 8.1 into BC 0.1. Okay, minus A 0.9 and D minus 0.9. Solving this one, we got the 0. We got the 9 and 81, no, 8.1. We got the 0. That's why we got the 0 here. Again, remaining 0. They are occurring here. One row is with 0 starting. How can we start the remaining part? How can you get the W naught value? Why? Because A, B, C, D. Again, W naught value is 0. Again, W naught value is infinity coming. Why? Because it is 0. That's why. So we go for the singular cases. That is, first of all, which row is there coming to 0? Above that row, we have to take as equation. Here we getting this row is getting here 0. This row we are getting here 0. So above row, what is this one? This one. If you take for this one equation 0.1, 0.9, no. So see 0.1 omega square minus 0.9 omega naught. The order, you check here order also. It is omega square value, it is omega naught value. Okay. So that is nothing but omega naught value 1 now. So that's why we have mentioned 0.9. Okay. After that one, you have to make it as with respect to omega derivative. What happens? This value is, that is 0.2 omega. 0.2 omega. So substitute this one here, where we got the 0 value, this way, this place, this place. This is a singular case. Another singular case. What happened in previous that one? It is, we are getting here in previous 0 and 0, where omega power 1 is there. Six 0 0, we got it. 0 0 at omega 1. But what happened here? 0.2 is came. 0.2 is came. Okay, next one. After that one, what is the omega naught value? Omega naught value is, okay, so ED into ED by 0.2 into 0.9 by, sorry, 9 minus, tell me, I'm writing here, minus 0.9, 0.2 minus 0 into 0.1 by 0.2, 0.2, this is 0, so only 0.9 is there, only 0.9 is there. So what happened? There is a one sign change. Okay, so all the roots are the right hand side of the double plane. Therefore, the system is, you have to take it as lies on the outside the circle. So, in the problem, they given as it is sign change, one sign change, one sign change. So, how many roots is there? 3 roots. In 3 roots, what is the one root is going to be outside. Outside. So, without the side. So, to verify the conclusion that roots or equations are, we found that z equal to 0.5, z equal to minus 0.8, and z equal to 2. That is, z equal to 2 is lies on the outside of the unit circle. Okay, outside of the unit circle. And inverse of z equal to 0.5, which is called as the all z rows are in double plane. All z are in double plane. Okay, this is the condition for the with different conditions problems. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.